So what I want to discuss is the difference between consensus or fact. So it's generally accepted fact that the universe came into existence out of nothing. Now this is contemporary, so we have nothing. A guy like myself would ask, well, how does it come out of nothing? But it's also a generally accepted fact as a consequence of the Big Bang, gravity is the genesis of all that we see. And this is all that we see. There's a lot there, and that's supposed to be due to gravity, and it's supposed to be due to the Big Bang, and all this came out of nothing, randomly, of course. And so it's a generally accepted fact that the core of stars became nuclear as a function of gravity. It's a generally accepted fact that black holes, dark matter, dark energy, and other dark things are responsible for making the universe work as it does. So we have a black hole, which is really nothing. They've never been measured. We have dark energy, which is another variable in a mathematical equation. And we have dark matter, which is also another variable in an equation to try to make sense of this universe that we see that came out of nothing. And of course, other dark things. So, but it was also a generally accepted fact that you could not sail faster than the wind for thousands of years, until recently. It was also a generally accepted fact that heavier than air aircraft could not fly until the last maybe 110 years or so. So we have two worlds. We have the theoretical and we have the empirical. I'm an empirical experimentalist. But like Newton, we don't deny the theoretical. We accept it as being necessary to develop ideas about what is going on in the world around us. I feign no hypothesis, and I contrive no hypotheses. I have not as yet been able to discover the reason for these properties of gravity from phenomena, which is his test. And I do not feign hypotheses. For whatever is not deduced from phenomena must be called a hypothesis or hypotheses, whether metaphysical or physical or based on occult qualities or mechanical, have no place in experimental philosophy, which is, in today's day and age, you might say is the scientific method. So these two worlds have been at war from the beginning of time. You have the theoretical, which is in modern terms called philosophical methodology, and empirical, experimental philosophy, the way you go about doing experiments. So philosophical methodology relies mainly on a priori justification. It's relating to or denoting reasoning or knowledge that proceeds from theoretical deduction rather than from observation or experience. And sometimes it's called armchair philosophies. While experimental philosophy makes use of empirical and experimental data. So you may say gravity exists, and you may say that the evidence indicates that gravity exists universally, but you may not claim that gravity is the primary driver of the universe. To make this claim means that gravity is the genesis of electricity and light, and that electricity and light are responses to gravitational forces. But there is no scientific data that gravity alone is a genesis of electricity and light. Do you have any water here at all? Oh, thank you, Michael. Is this bath water?
It's genuine bath water, honey.
Thanks. So I want to get on to Albert Einstein because a lot of people criticize him. But what he had said is that all knowledge of reality starts from experience and ends in it. Propositions arrive at by purely logical means are completely empty as regards to reality. This is Einstein. Because Galileo saw this, and particularly because he drummed it into the scientific world, he is the father of modern physics, indeed, of modern science altogether. But he went on another lecture in Oxford. If you want to find out anything from theoretical physicists about methods they use, I advise you to stick closely to one principle. Don't listen to the words. Fix your attention on their deeds. To him who is a discoverer in this field, the products of his imagination appear so necessary and natural that he regards them and would like to have them regarded by others not as creations of thought, but as given realities. This is Einstein, and he gets a lot of criticism But he did hold to another view, and he questioned his own theories.
You need to know that black holes, dark matter, dark energy have never been measured. They're mathematical variables in mathematical equations that have been deduced. This may be acceptable as philosophical methodology, but it is not the scientific method and cannot be promoted as scientific fact. These claims have nothing to do with empirical science and are completely empty as regards to reality. It doesn't mean they don't exist, it just means these things do not qualify to be promoted as scientific fact until they can be measured and quantified as contributing factors to the natural process.
And we do theoretical physics, computational fluid dynamics, and it's a tool, but it doesn't quantify what is going on in sapphire. The humble hydrogen atom. We have a proton, we have an electron. The electron has a negative charge, we don't know why. We suspect a proton has a positive charge, and we don't know what that's about. We don't know why it is that positive and negative are attracted, but we know they are. And if we stretch the electron out from its orbit and it wants to come back in, it releases a photon. And some would say that a photon is a particle. And so I asked a physicist one day, so I said to him, well, if we excite a hydrogen atom and we can do it indefinitely, and he says, yeah, we can do it indefinitely. I said, so, and it's a particle. I said, yeah, and it creates a photon. I said, creates a photon. I said, that's really interesting. So does that mean that the hydrogen atom has an unlimited supply of photons? Now this guy has got 83 papers published, peer-reviewed. He was the editor of the IEEE, really good guy. But in that question, there was that 3-second silence that felt like an eternity, because he knew where it was going. So I said, does this mean that it has an unlimited supply of photons? I said, or does it create them? And even that was a silence, because what we're saying in effect is that when we excite the hydrogen atom, we're creating a particle out of nothing. Being an experimentalist, I'm cool. Like, I don't have to have the answer. And so we just left it at that. So questions in my mind came, well, if it's creating a particle out of nothing, does that mean that when we create light that we're actually adding mass to the universe? So it's okay if you don't know. It's not okay if you think you know and really you don't. Knowing something is a result of conducting a scientific method, investigating natural processes. So we collect data. And you do it all the time. You make decisions based on information that you have coming into you today.